Well, in this problem we have three arrangements A, B and C of identical particles, which means each particle have same mass. So we want to find out the magnitude of the force acting on the center mass from other particles. If I say the force acting on this due to the other three particles, I mean the net force, then if it's Fa, and similarly the net gravitational force acting on this particle Fb, and similarly here Fc. Okay, so we want to find out the relationship between these three forces. Okay, so if I consider this first one, okay, here I can, okay, if I consider this one, the force acting on this will be from, let's say, the gravitational force between two particles. Here let's say each have mass m. So if all particles are identical, so each and every particles have mass m, and since the particles are in a circumference of a circle, the distance from particle to the center particle also same. Let's take the radius of this is simple r. Okay, so I can write the force between one particle on the circumference and the center particle, that is going to be equal, I can write, that is F is equal G m over r squared, right? The force acting on this particle due to this, that's going to be in this direction F, and due to this it's going to be like this due to this particle, and it's going to be like this. So now we can see here these two particles are in the same in the diameter, same diameter. So this F and this F cancels off, therefore the net force acting on this particle is going to be in this direction F, right? So I can say Fa is equal to F. Okay, and similarly we can mark the force acting on this one, that's going to be F, and this is F, and this is F. Okay, and here I can, if I take this angle theta and this angle also theta. Okay, so the total force acting on this particle will be F plus F cos theta plus F cos theta to F cos theta. So we know cos theta, this theta angle is between 0 and 90, therefore I can say this overall term is greater than F, right? And similarly if I consider this one, here F, and this is also F and F, and this angle is small. Okay, I take this beta or something, so I can write this Fc is equal F plus 2 F cos beta. This also I can write greater than F, then I can say angle theta is greater than beta. We know when the angle increases, the cos value decreases, right? So this cos value is less than this cos value because this angle is smaller than theta, therefore this has small value, right, compared to this. So now I can write the relationship. So smallest is Fa, right? So Fa is smallest, and then next is Fb, and Fc is the greatest. So I can write this is the relationship between Fa, Fb and Fc. Okay, so the answer is first one is the answer. Okay, okay, in this problem we have two rods with same length and same mass, but shapes are different, and we want to compare the gravitational force acting on this point mass due to this rod and this rod. And I'm going to consider 2 point masses, one simple M and other one capital N, separated with distance simple r apart. And we know by using by Newton's law of universal gravitation, the gravitational attraction force between these two masses, these 2 point masses, I can write F is equal G m over r square. Here we can directly write an equation for the gravitational force between these two point masses, but here we can't do that because these are not point masses. In fact, Newton's law of gravity explains or valid only for point masses. So what can we do? So for that I'm going to cut this into point masses. For example, I can cut this into n number of point masses, so I can write m is equal n times m, where m is the I take m naught, where m naught is the mass of a point mass. So I cut this into n number of pieces. Okay, and here this one also I can cut into n number of pieces, so they are also going to be, because the mass is same, so each point mass going to be m naught. So here if I compare these two, so if you notice, this is the arc of a circle. That means the distance to every point masses on this rod is going to be same. But if you consider this, so if I consider point mass somewhere here, distance between these point masses and this mass is going to be more than r, right? Not r. If you go further and further, that distance will increase. Okay, and if you go in this way also further and further, that distance will increase. So we know the force is proportional to 1 over r squared. So distance increase means the force decreases. So if we compare this Fa and Fb, I mean the force acting on this point mass due to A, let's take that is Fa, and the gravitational force acting on this point mass due to this rod, I mean the net force Fb. The net gravitational force acting on this mass due to this rod is Fb, and net gravitational force acting on this mass due to this rod is Fa. So if I compare this Fa and Fb, what I can say, Fb is greater than Fa, because here distance is increasing, so gravitational force decreases. Okay, so now we have compared Fa and Fb. Now what we have to compare is Fa and Fb with F, where F is the gravitational force between 2 point masses. So here I'm going to consider Fb. I'm going to compare Fb and F because it's easy for us to do, because here the distance also varying. So I'm going to take so if I compare Fb and this F, now we can see this F is confined to 1 point, so this directly acting on this way. So but here what happens, this total mass is distributed some over this arc. Okay, if I consider here a point, let's say a point mass m naught, and the gravitational force between these two I can write F naught, and then F naught is going to be g m naught over r square, and from this we know m naught is m over n. But what we have to do is we want to resolve this into vertical component and horizontal component. Okay, so horizontal component, for example, this angle is theta, f cos theta, and this is f naught sin theta. So if you take each gravitational force between each and every point mass on this arc, and the summation of vertical components is going to be, I mean vector summation of the gravitational force acting on this point mass is going to be 0. But the horizontal, we want to take f naught cos theta, we want to integrate all over these point masses. Then if we do that, we will obviously get that value is that is Fb is going to be less than F. Okay, because this mass is distributed here, so we always get a component of this, so that's the reason. So from this, what actually the answer is, I can write Fa, sorry, I write here Fa Fb g m over r square, where that is F. Okay, so the answer is fourth one. Okay, fourth one is the answer. Okay, and the next one, okay, this is a very easy problem. If you understand the physics here rather than addicted to equations, you can find their answer for this without wasting a drop of ink. Okay, it says this mass m in equilibrium under the influence of these two masses. Therefore, I can write F1 is equal F2, where F1 is the force acting on this mass due to this mass, and F2 is the force acting on this mass due to this mass M2. So F1 is equal F2. So I can write G M M1 over R1 square is equal G M M2 over R2 square. Now this mass is doubled. If this mass is doubled, what happens? This force also increases twice. So in order to keep this mass balanced, we have to increase this force as well. We can do that by bringing this mass closer to this mass. So bringing this mass closer means the R2 will have a value less than 2a. So given choices, under the given choices, the only value which has less than 2a is this one. So answer is the second one. Here I didn't do any max and not even necessary to write these things. Anyway, now I'm going to calculate this in exact way. So from the initial condition, I got this equation. So here GM cancels off. So I can write M1 over R1 squared is equal M2 over R2 squared. So M1 over R1 is 3a, so we get 9a squared is equal M2 over 4a squared. I take this as my equation 1, and now this mass is doubled and we want to move this in order to keep this balance. And let's say I don't know that distance, so I take that to be x. So I can write again the gravitational force balance. So if that is remains balanced, so I can write G M times 2 M1 because the mass is doubled now over 9a squared is equal G M M2 over, so the distance I don't know want to find, I take x squared. So from this again G M cancels off, so I can take this to this side, then I get M1 over 9a squared is equal M2 over 2 squared. So from this equation M1 over 9a squared, I can substitute this term, so I get M2 over 4a squared is equal M2 over 2x squared. So M2 cancels off, so I get 2x squared is equal 4a squared. Therefore I get x is equal root 2a. So that's how x equals to root 2a. So that's the new distance between mass m and mass m2. So here you can see I took this long to get the value, but instead if you realize that distance has to be less, then you can save this much of time. So what I'm trying to tell you is physics is not subject that you have to study by memorizing or solving problems by addition to the equations, but you have to think and understand what's happening there, what's actually, because physics is reality, you have to understand reality. Anyway, so the answer for this one is the second one then. Okay.